Now that we know what electricity is and how electrons move, it's time to put that knowledge into a real-world context. Basic circuits. One of the biggest ideas from our previous lesson was electrons like to move from areas of high concentration to areas of lower concentration. In other words, electrons like to move from areas that are more negative to more positive. And that's because they're attracted to positivity, just like us, right? Anyways, the big question now is, how do we control the movement of these electrons? That's where circuits come in. A circuit is simply a pathway that allows electrons to follow. Think of it like giving electrons a GPS route that they can follow. Let's start with an example. So this is our battery, and it has two terminals. At the negative terminal, there are more electrons. So we see that there is a higher concentration. But in the positive terminal, there are less electrons than the negative terminal. So we say it has a lower concentration. The extra electrons on the negative side want to go over to the positive side with fewer electrons so badly to create balance. But electrons can't just float through thin air unless you've got some crazy energy levels. And we're talking lightning levels, by the way. They need something to travel through. And in our everyday life, wires give electrons a path to flow in. For example, the wires in your house are what allow electricity to flow through and power your light bulbs. Without them, no light. When electrons move from one terminal to the other, we usually want them to do some useful work for us along the way. Again, like powering a light. Let's take a look at a sample circuit of a battery and a light. Imagine the battery is a house. The front door is the negative terminal side. The back door is the positive terminal side, and between the two, a little journey to get to the other side. The light bulb in the middle is like a nightclub for the electrons. That's where they go to light it up. Literally. They pass through, use their energy, and keep on moving. Then they move towards the positive terminal back door where they sleep, regain energy, and then once they regain energy, they slide back down to the front door and keep on going. They keep on repeating over and over and over again. Let's summarize everything so far. So the battery is our power/energy source. Electrons leave from the negative terminal side and come back in through the positive terminal to regain their energy and be able to keep on going back and forth. The wires are a pathway that allows the electrons to move. The light bulb is their energy fun spot. Well, that's where they go to use up their energy. And so from that, we know that the sequence in this circuit is negative terminal going to light bulb to the positive side, and we know that this keeps repeating over and over again. We call this circular repeating path a closed loop. That's what keeps everything working. If the path isn't closed or complete, that means that the electrons have nowhere to go and the light stays on. The electrons need to go back to the positive terminal to rest and regain their energy to be able to keep flowing through the circuit. Without this, electricity won't flow. And that's known as an open circuit. Now, earlier, I said that electricity or electrons move from the negative terminal to the positive terminal. But I'm sure you've heard people before say that electricity flows from positive to negative. Let's clear that up. Back in the day, Benjamin Franklin, one of the first people studying electricity, assumed that electricity flowed from positive to negative. Back then, no one knew about electrons yet. So they kind of rolled with it. By the time they discovered electrons and realized which way they flow from negative to positive, it was already too late. The positive to negative model was already baked in engineering textbooks and circuit diagrams. The good news? You can use whichever one you want and you'll be fine, as long as you stick with it. We now have two models we can use to describe the way electricity flows. There's the electron flow model, which is the one we've been using so far in this course, and that says that electrons move from negative to positive. On the other hand, we have Benjamin Franklin's theory, and that's called the conventional current flow model. Current is just another way of saying the flow of electricity/electrons. And this model states that current flows from positive to negative. Moment of truth. Which one are we going to use in this course? We're going to use the conventional current flow model. I know, just when you were getting used to the electron flow model, we're switching it up on ya. Why are we using this model? Well, like we said earlier, it's the industry standard, and it's also what textbooks and exams use. And last but not least, it keeps circuit diagrams pretty clean and easy to read. So even though electrons technically move from negative to positive, we'll pretend they move from positive to negative for the sake of simplicity and consistency. Here are our final takeaways for today. Electron flow describes the actual movement of electrons, which is from the negative terminal to the positive terminal. Conventional current flow, on the other hand, is the industry standard for circuit diagrams and assumes that current flows from the positive terminal to the negative terminal. Both models are valid so long as you stay consistent and remember which one you're using. It's also important to remember that electricity will only flow in a closed loop. No closed loop, no current. And finally, circuits aren't just about movement. It's also about guiding the energy of electrons to do something useful for us, like powering a light bulb or powering a device. Next up, we've got one more concept to cover, and then we move on to our very first lab. Get ready to build something. See you in the next one.
If you like what you've seen so far, you should visit our website and check out our electronics and coding kit. It comes with all the videos, all the lessons, all the code, all the labs, and all the project files. So yeah, link in the description, and happy learning.